Mm, uh, let it first load. I don't know why this Jupyter notebook this time around is taking long to load. It has loaded. We are going now to start in a topic known as iteration in Python programming. Last week, we touched at conditional execution. And that conditional execution, I taught you on how to write a condition in Python programming. And a condition, I told you it must end with a colon. And what follows is normally a block. And a block is what you expect Python to execute. I taught you also the indentation. After you have written your condition, you have to follow the indentation rule. Otherwise, you will obtain what we call indentation error in Python programming. In the same last week, I taught you how to now handle the nested if, and I told you this is where now if is followed by another if. That is where we call it the nested if, and we carry out some examples of the nested ifs. And then I thought the same last week, I told you to now look at one or two programs where you are supposed now to apply if-elif statements. And one of the examples which I wanted you to measure on, it was the grading. We normally use if-elif statement in grading. And I wanted to make a Word document within the week so that I can send it to you as a project. But my schedule has been so tight, I didn't get time to do so. But I promise, I think I'll do that by tomorrow, or by, I think, on Monday or Tuesday. But I really want to appreciate there are some people who have done already some practice and they have sent to me in my mail. And what I can say, you have done a wonderful job. So last week we just touched on if statements, and then we touched on how now to come up with a condition in Python programming. And after you have come up with that condition, I taught you how now to execute that condition. And the execution of that condition is what we call the block statement in Python programming. So today you are going now to chapter 5. Which is now about iteration. And I told you now there are some codes which you will meet in Python programming that are repetitive in nature. So you are going now to see how to handle those repetitive codes in nature. And we'll cover definite, indefinite, infinite loops. Now, in our last week's class, we measure on if and nested if statements. Now, when we go to iteration, this is where now you will use the while statement. And the while statement is normally used now when you want to make a loop. And when you want to make a loop, that means there are some statements that will be repetitive. That is why we call it iteration. So in this chapter, we'll measure a lot on while for statements, while for statements, and what have you. And also in this chapter, that's where now you'll be able to write a range in Python programming. If I can start by saying that iteration repeats the execution of a sequence of a code. Iteration is useful for solving many programming problems. Therefore, iteration and conditional execution form the basis of algorithm construction. So you have to know that iteration and conditional execution, which we have covered in chapter 4, it is what forms the basis of algorithm construction. Now, the process of executing the same section of a code over and over is known as iteration. So the process of executing the same section of a code in a repetitive manner, that is what we call iteration, or we call looping. And as I've told you earlier, in looping, what we will start with, it will be a while statement and a for statement. So there are two statements that enables iteration or looping, if I can say in a nutshell. That is while statement and for statement. Now we will start with an example of a while statement. And we'll just go the same procedure the way we have been handling the if statement. In this example, you see here, I'm setting, for example, I want to count things. And when I want to count the values which I have, I want them to be counting in a range of 100. So I will start by setting my count. So that is why you see here I've written count is equals to 100.
Mwalimu, are you sharing the screen? Because we can't see the screen from your end.
Yes, I'm sharing the screen.
We can't see it. Or because me, I don't know whether others are seeing it. Maybe
no, we can't see the screen.
Okay, let me share it again. I don't know what happened. Are you in a position now to see my screen?
Yes.
Okay, thank you very much. So let me start that iteration. So iteration repeats the execution sequence of a code. So iteration is useful for solving many programming problems. Therefore, iteration and conditional execution forms the basis for algorithm construction. And you have done conditional execution in chapter 4. So this is what it forms the basis of algorithm construction. Now, the process of executing the same section of a code over and over is what is called iteration or looping. There are two statements that we are going now to use in this chapter. And the first statement is the while, and now the second statement is the for statement. So the while and the for statement are two major statements that are used in iteration or looping. The first example which we are going to start with is the while statement. We'll see how to execute a while statement. And I've told you that a while statement or a for statement is what we use in iteration. Why are we going to use this? Because it allows repetitive sequencing of a code. Now, for example, I want to count some values. And when I want to count this value, I want to put them in a range of 100. The difference between one value and the other should be 100. So I will start by setting the count, or in programming, we normally say to initialize the counter. So I'll say counter is equals to 100. After I have initialized my counter by saying count is equals to 100, now I will introduce the while statement. So I will say while count is less or is equals to. We learned about inequality sign in our chapter 4. So I told you when you want to show a value is less than or is equals to, so you normally put that less than sign and is equals to. So you say while count is less or is equals to 1,000. So it means, what does it mean? It means you want to count from 100 up to 1,000 with a difference of 100 in between the values. So I'll say while a count is less or is equals to 1,000. Then you see I'm ending with a colon. That means I've put my condition. So after I've put my condition, what should follow is what we call a block. And I told you when you are writing a block, it must be indented. When you will fail to indent your block, it will give you an indentation error. That is why now you see when I'm writing my print, I say now print count. So I'm expecting now the program to print for me now the counts. And this counts, it is now from 1. This count should reach the maximum of 1,000. Now, you see now, there is another statement there, another code there, count plus is equals to 100. So that means I want now, when it will be printing up to a limit of 1,000, it should, the difference between one value to the other should be 100. So that is why when I run this code, let me run. When I run this code, you will see that it has printed 100, 200, up to 1000. Why? I started by saying count. So count that I'm setting where now my count should start, and I've set it to 100. So I've set it to 100. So this means it will start counting from 100. Then I've said while count is less than or is equals to 1000. That means the code will pass through an iterative process, and when it reaches 1000, it exits the loop. Then I'm instructing now to print count, and this count should be in a difference from one value to another, in a difference of 100, 100. Now, what if I set now my count to be 200? What if I set my count to be 200? Let us see. You see, when I've set my count to be 200, that means I am initializing my first value to be printed should be 200. Then it should reach a maximum of 1000. Then now I'm retaining the same count. You have seen here I'm saying count plus is equals to 100. That means the difference should be 100 from one value to another. If I want here, maybe the difference to be 300, and I run my loop, you will see it will have the difference of 300, starting from 200, 500, and then 800. Because now the next value from 800, it will be 1100. And you see I've said here while count is less or is equals to 1000. That means 1100 is outside the loop. So it will just print from 200 to 800. But when I just retain it as a difference of 100 and I run my loop, you see it will start from 200, then up to 1000. What if now I set my value to be 50? When I set my value to be 50, it will just undergo the same process. My first value will be 50, and the second value, because now I've set the difference to be 100, the second value will be at 150. The second value will be at 150, and it will go that way up to 950. That means now the other value will be at 1050, and since 1050 is greater than 1000, that means it is outside the loop, so it will not print. So what I've written here is a while statement above. It repeatedly displays the value count. So that is what I've taught you. When you use that while, that is an iterative statement. So it will repeatedly display the counts up to when it reaches the loop, the limit. And when it reaches the limit, it just exits the loop. That is just a flow diagram of that program, which I have illustrated above. During your free time, you'll just follow the flow diagram. Now, the second thing is now when
sorry, could I just ask, if you go up there, I'm sorry, but if you go up there, you have a printed count, print count up on your notebook. There is that count, print count, then count. Is it plus equal or something? I don't know.
Yeah, that is plus equal to.
Okay.
That means now the difference from one value to another, there will be a difference of 100.
Okay.
That is why you see now it has started printing 50, and then it goes to 150, 250, 350, repeatedly, up to when it reaches now where I've set my count. And what have I used to set my count? I've used the while statement when I have said while count is less or is equals to 1000. So because the next value will be 1050, and 1050 is not less or is equals to 1000, so it will exit the loop. That is the flowchart diagram of that code. This is the flowchart diagram of the code which I have written. Now, as you can see, I've in the above flow diagram, the condition is checked before the body is executed, and then checked again each time after the block has been executed. If the condition is initially false, the block is not executed. So when it is initially false, the whole block will not be executed. But if the condition is initially true, the block is executed repeatedly until the condition becomes false, at which point the loop terminates. Now, in the second example, in this second example, I'm setting my entry. And after I've set my entry, you see I've said that now my entry is equals to 0. So that means I'm setting now the initial condition. I'm setting the initial condition. And now in this program, I want to do a sum. So also I will initialize my sum. I will say sum is equals to 0. Then, because I'm making the program, I'll start by saying I'm now requesting the input from the user. And when you are requesting the input from the user, you use the print. So I'll say print, enter numbers to sum. Negative numbers enters the list. Negative numbers ends the list. So I'm making this program in such a way when a programmer will try to enter a negative number, it ends the list. So what will enable me to do that? What will enable me to do that is by using now the while statement together with the if statement, which we did in chapter 4. How are we going to do it? So you say now, I say while entry. So this means when I say while entry is greater or is equals to 0. So you see there I've written a negative number exits the loop. So this is the condition that I want to execute. Sorry, I was thrown out of the meeting. So when I say, let me share my screen again. I don't know why it is throwing me out. Okay, when I say while entry is greater or is equals to 0, that means this program will only accept a number which is 0 or greater than 0. This program is going to accept a number which is 0 or greater than 0. So you see, I've said while entry is greater or is equals to 0. Then I've ended my statement with a full colon. That means that is my condition. Then I have to specify now, I have to request this entry from the user. So I'll say entry is equals to eval then input. And I've told you when you use the eval function, it means the program is going to accept either an integer or a float. Then I say now, I start now my other condition. The first condition, it was a condition to enable me to loop. It was a condition, an iterative condition. I have told you when you use the while statement, that is an iterative condition. It enables iteration, a repetition of that code. So in the second statement now, I'm going to use if, which we have covered in chapter 4. Now, if, this means it is a condition that answers true or false statement. So I'm saying if entry is greater than or equal to 0. Now, if it is greater than or equal to 0, what should now the program execute? What I'm telling my program, it is to sum. Then you see here plus is equals to entry. So I'm saying it now, it has to print the sum of the numbers which I have entered. It has to print the sum of the entries which I have entered. Then the last statement, now I'm instructing my program to display all the sum of all numbers that are greater or equal to 0. It exits. I don't know why this Zoom is throwing me out and in. I don't know. Now, this program is made in such a way that when I enter a negative number, it exits the loop. But when I enter a number which is 0 or greater than 0, it sums those numbers. And what enables this program when I enter a negative number to exit the loop? It is a while statement. And what enables this number now to sum the numbers which are greater or is equals to 0? It is the if statement. For example, now when I run, you will see when I will enter a negative number, the program will the program will exit the loop, because when a loop statement find a statement that it find anything that it is not satisfied in the program, it exits the loop. For example, I enter -5 and press enter. You see, it will exit the loop and it will tell me the sum is equals to 0. But now see, when I enter 45, then I press enter. You see, it asks me for the second value. When I enter, for example, 46, I press enter. It asks me for another value. The same way until when I will enter a negative number. Until when I will enter a negative number. You have seen it has accepted 45, 46, 78, 89, and 7. But when I try to enter -6, it will exit the loop. And after it exits the loop, it gives me the sum of all the positives number, and it assumes that negative number. So that is one application of a while statement. A while statement, it will enable you to exit the loop if all conditions are not satisfied. Now, the other thing, this example, you will do it by yourself. This example, which follows this second example, you'll do it by yourself. It is a very, very long example. This is where now, for example, you are a computer technician. You want to make a program which it will guide you to see if your device is faulty or not. So it also applies the while statements, because the while statement, it will enable the iterative procedure. And also it will apply the if statement, because the if statement, it is now the statement which will enable you to know if the device is good or bad, because as we learned earlier, the if statement answers the question true or false. Another thing we're going to cover is definite loop versus indefinite loop. We'll start with the definition of a definite loop. A definite loop is where we can inspect the code and determine the number of iterations the loop performs. This kind of a loop is known as definite loop. So a definite loop is where we can just inspect the code and determine the number of iterations that a loop performs. Example of a definite loop. You see here, we have set our n to be 1. We set our n to be 1. That means now the same way we are setting our count to be 100. So that means where the count will start, it will start at 1. Now, because we want to make a loop, and I've told you, when making a loop, we in this chapter, we'll majorly use the while statement or the for statement. Now, we will start by writing our while statement. We'll say while n is less or is equals to 15. While n is less or is equals to 15. So that means when n is less or is equals to 15, it has to print for us the value of n starting from 1 up to 15. So that means we have set, we know the counts, the maximum count will be 15. So this is an example of a definite loop because we can determine the number of iteration in that the loop performs. How can we determine the number of iteration that the loop performs? You see, I've started by initializing my n to be 1. And then I'm setting now the loops. I've said while n is less or is equals to 15. That means it is going to perform 15 loops. That means it is going to perform 15 loops. And I've said, and I'm now setting my n is equals to 1. I'm setting my n plus is equals to 1. That means from one number, when it will be counting, from one number to the other, there will be a difference of 1. So when I run this code, you see it will display for me from 1 up to 15. And what has enabled me to know there are 15 loops, you see I had set here while n is less or is equals to 15. So I knew my last number will be 15. I knew my last number will be 15. Now, after knowing that my last number will be 15, I've set now my n plus is equals to 1. This is the difference between one number to the other. So I knew that the difference from one number to the other will be 1, 1. So it means I will be having 15 different loops. So when you know a number of iterations that a loop performs, that is an example of a definite loop. For example, when I set it to 2 and I run, you see, I know my last number will be 15. But this time around, the difference will be 2. Now, I will know the loops will be 1, 2, 3, 4, 5, 6, 7, 8. So I know it will give me 8 loops. So when in a definite loop, this is where you determine the number of iteration that a loop performs. The second example, you see here, I've set now my n to be equal to 1. Excuse me. I've set my n is equals to 1. Then I say now, stop. I want to set now where my loop will stop. I want to set where my loop will stop. This is just the same thing as how I have done in example 1. But now in this second case, I want to set where my loop will stop. So you say, you see I've written stop, then I've written equal to int, input. So this means I will, this is a progressive loop. This is a progressive loop. You can decide your loop can go up to 100. But in this first one, this one was going only, it was only specifically for 15, up to 15. But in this one, you can enter 20, 30. So that is why now you see here, now I'm setting my stop. After initializing n is equals to 1, then I say stop is equals to int input. This means now I'm requesting an integer value from a programmer, which he or she wants is or her loop to end. Then I say, while n is less or is equals to stop, that is my condition, what should it execute? I'm telling now my loop to print n. So for example, let me make it the same way like the one above. I put it 2. So in this one, when I run this loop and I say now it has to reach 15, I will have to put here 15 and then I press enter. You will see it will give me the first, the same results as the one we got above. For example, in the one above, when I set it to 1 and I run, you saw it gave me from 1 to 15. So it means I was able to determine my loops. And in this second one, when I put it the same one and I run it and I put 15 here, you see it will give me also from 1 to 15. So it means this first value, I was able to determine the number of loops that I want this program to undergo. After that, I have told you the difference between the first one and the second one. The first one is just specifically for 15 loops, but in the second one, you can just enter any number that you want. For example, if I enter 30 and I run, you see it will give me 30 different iterations or loops. So what I want you to get, indefinite loop is where the programmer determines the number of loops. But in now, when you go to indefinite loop, the programmer cannot determine the number of iterations or loops. So definite loop, a programmer has got that freedom to determine the number of loops or iteration. But in definite loop, a programmer doesn't have that freedom to determine the number of loops or iteration. Example, a definite loop, as I've told you, you have to set and you have to enter the loop at least once. So this means you have to enter the loop at least once. So I've started by what I taught you in chapter 4. Conditional execution answers a false or true statement. So you have to set it to be either false or true. So why am I saying done is equals to false? This means when you enter something and the loop finds it to be false, it exits the loop. But when you enter something and the loop finds it to be true, it doesn't exit. So that is why you see here, I've said done. So done is equals to false. I'm setting now my loop. If it will find a false statement, it exits the loop. But if it finds a true statement, it doesn't exit the loop. Now I say, while not done, that is my condition, which I've ended it with a full colon. A condition must always end with a full colon. Then it is followed by a block. And as you can see, my block is indented. Now I'm requesting entry. I say entry is equals to eval, then input. And I've been telling you time and again, when you use eval, it means the program will accept either a float or an int. Now, I apply now the if statement. Now I say if entry is equals to 999, that is my condition. What should now the loop execute? I said done is equals to true. So if entry is equals to 999, I've set now my loop to say done. So if I enter value 999, this will enable now my loop to exit. Else print entry. So when I enter any value, which is not 999, it will print it. But immediately I enter 999, it exits the loop. Let us run this code. For example, I enter -5. You see it executes and it asks me for the other value. When I write 0 and I enter, it executes and it asks me for the other value. When I write a number such as that is 1 million, you see it executes and it asks me for another value. I enter 234, it executes and it asks me for another value. But when I will enter 999, it will exit the loop, because in my condition I've said if entry is equals to 999, it prints, it exits the loop, because I've said done is equals to true. At first, why has it accepted -5, 1,234,000? Because when I was starting my statement, I initialized my loop by saying done is equals to false. When I want now to finish my loop, I have to say done is equals to true. So when I enter that, you see now it exits the loop. It doesn't give me any other bar for me to enter a value. It doesn't give me any other bar for me to enter a value. So this is one example of an indefinite loop. You have seen you can enter as many numbers as possible because you can't determine how many loop an iterative can perform. But in definite loop, you saw there, I decided it is only 15. It is only 30. But here you can enter an infinite number. You can't determine. The for statement. Now, the for statement, it will enable you as a Python programmer to enter a certain range. To enter now a certain range, you want to deal with a range. For example, your range, you want to enter a number from 1 up to 100. You want to enter a number from 1 up to 100. In this case, you will use now the for statement. This for statement, it will enable you now to enter numbers in ranges. Now, from the example, also when you are writing a for statement, it must end with a full colon, because that is a condition which you want your program to execute. Now, after writing that, your for statement ending with a full colon, you have to intend the block part of it. For example, in this code, I want now to write a range which will cover a number from 1 to 10. I want to write a range which will cover a number from 1 to 10. So this is where now you will require some little knowledge of algebra that you are taught in campus. A for statement, it is just algebraic, as you can, any person who has ever passed through college mathematics, you can witness. So you say for n. This is how we, those algebraic, especially in set theory, it is written, how it is written. If you are just good in set theory, it will not be anyhow difficult for you. So for n in range. So this means we want to print values within n. So we say for n, you can use any number. It is not a must for you to use n. So don't cram n. You can use x, you can use w, you can use, even you can decide and use your name, Levi, it will just give you. So in this example, you see, for n in range 1 to 11, you are, there is something which I want you to note. If you want to write 1 to 10 in Python programming, you have to write 1 to 11. I don't know if you are getting me. You have to write 1 to 11, because Python programming, as you saw when you are trying to import those data sets, it starts counting from 0. It starts counting from 0. So that one which you are seeing there, it is index 0. It is index 0. So when you want to count from 1 to 10, when you are using the for statement, you have to write 1 to 11. When you want to write 1 to 100, you have to write 1 to 101. So that is how Python language is normally is. So for example, I want to write a number from 1 to 10. I will say for n in range, then 1 to 11. Then I say, I put a full colon. Then I say print n. So when I run this code, it will display for me numbers from 1 to 10. And I've told you, here you can use any number. For example, you can even decide for, you say Levi. So that is your set. For Levi in range, so you want to print 1 to 20. And I told you, when you want to print 1 to 20, you will write here 1 to 21. Then here in bracket, you just come and print Levi. This way. So when you will run, you see it gives you 1 to 20. it gives you 1 to 20. So it is not a must for you to use what? N. You can decide and use X. So long as you remember the statement 4 in range. 4 in range and those brackets and the full colon. So you can say for X in range 1 to 20. So it will give you it will give you now 1 to 20. So you have seen there, I've said for X in range 1 to 21, print X. And I've told you when you want to get a range from 1 to 20 in Python, when you are using for statement, you have to say for X in range 1 to 21. That is the first example. And this first line, as I've told you, it is the condition. Then the second line, it is the block. Further examples. Now, for example, you want to print a range, and this range is in descending order, and it has the difference of 3. It has the difference of 3. You want now Python to print for you a range from 21 downwards in a difference of 3, 3. So you will say for n in range, then you put 21. This means now it will start printing from 21 in a difference of 3, 3 downwards up to 0. So you'll say for n in range 21, then 0, negative 3. This negative 3, it means it will print in a difference of 3, 3 downwards. So when and say now print n, so this print n, end is equals to those quotation mark. That is just the standard form of writing that n. You can, the other one can write print just n. You can just decide and say print n. Well, let me copy paste here. The first person can write it this way, and the second person just and write it, come and write it this way. Just come and say just print n. It will just give the same thing. So when you run this code, you see it gives you 21, 18, 15, 12, 9, 6, 3 in a difference of 3, 3, 3 downwards. It has started from 21, then 18, 15, 12, 9, 6, 3. That is a difference of 3, 3 downwards. Then you see when I do the same here, it has just done the same thing, but you see now the other one was horizontal and this one is vertical. Why am I getting the horizontal and vertical? Because now you see here, I've said print n, then I put those quotation mark, print n, comma, then those quotation mark. So that means I wanted it to print for me vertically. This quotation mark is the one which takes care for vertical printing. It is not even those quotation mark. Let me remove the quotation mark. Let's put it this way and I print. A little bit. Yes, these are two different things. As I was teaching you the different ways of printing, when you write it in a standard way and you see it will be printed on the same line. But when you just write print, it will be printed in different lines. So when I write it without this quotation mark, it combines. But when I write it with a quotation mark, it acts like a separator. That is why the other one, it is printed vertically and the other one is printed horizontally. Then the other example of how you can use the 4 the for statement. For example, I initialize a little bit. So the other example, for example, I initialize sum. I say sum is equals to 0. So that means I want to initialize now. It is the same thing which I was doing in the other program. So I say sum is equals to 0. That is initialization. Then I say for I in range. For I in range. That means now from 10 to 100. From 10 to 100. So that means when I will enter any number in between 10 to 100, what now I'm making this program to do is to sum I, is to sum now for that I. Then I print now the summation of I. I don't know if you are getting. Let me repeat. I've started by saying sum is equals to 0. Then I'm saying for I in range, for I in range, that range is 10 to 100. So I'm making a range in this program, and within this range, I want the program to do the summation of all the values from 10 up to 100. To do the summation from 10 up to 100. So what will it mean? This means this program is going to do the sum starting from 10 up to 99. It will do for the sum of 10, 11, up to 99. So I told you, when you see 10 to 100, this 100 in Python programming, you normally subtract 1. So this means this program is going to make the sum of all numbers 10, 11, 12, up to 99. So I'm saying sum plus is equals to I. So that means I'm going to do a summation of this I, which I've said for I in range. And this I, it is between 10 to 100. Then I print sum. So when I will run this program, you will see it will give me 4905. That means all the numbers in between 10 to 100, their summation is 4905. For you to get it clearly, let me enter a small number. Let me enter a very small number. For example, I enter 5, 1 and 5. 1 and 5 that way. And then I run 1 and 5. It means it will take 1 plus 2, which is 3, plus 3, which is 6, then plus 4, which is 10. So it will take the summation of 1, 2, 3, and 4. So this is what it means by this program. Other examples. For example, you want just to get, I've given you how you can use now the for. The for statement. But now ask yourself, you want just to get now the range of maybe 10 numbers. You just come here and say range. Then in bracket, you just write 10 and you run. Why is it not giving me 10? Range 10. Okay, let me say x is equals to, then I call it x that way. No, something which I want to bring it out. Let me just teach using this. So when you see now, you have used now the for together with the range. When you see range 10, that means you are going now to print a number, which is 0 up to 9, which will just be the same as range 110. As you have seen, it will still print the number 1 up to 9. Yes. Yeah, the difference is here. When now you see just a programmer has specified range 10, it is the difference, it is different to when you see now range 110. In range 10, you see 0 is included. It will start counting now from 0 up to 9. But when you see range 1, then range 1, then 10, this means it will start now counting from 1. It will start counting from 1 up to 9. Now, I want you now to get this example here. I want you to get this example here. Now, for example, here, you see I had put 110. So when I will run this program, it will start from 1 and it goes all the way up to 9. It goes up all the way up to 9. This code is different to if I will do this. Let me copy paste and then I make another cell. It is different to this. It is different to this. When I will run this one, it will start now counting from 0. It will start counting from 0 up to 9. But in this one where I had specified my range to be 110, it started counting from 1 up to 9. But in this one where I've just said range 10, it started counting from 0 to 9. So I need you to get those differences. Now, in this one, you see I've said range 110. Yvonne, remind me when it is 6:27 so that people can go for a break of around 5 minutes. So okay. In this one, in this one here, you are seeing now range 110. This means now 110, then you see here I've put 2. This means I'm going to print 1 up to 10 in a difference of 2 as ascending order. Let me do it this way. You see here, that is where I show you the descending order. Yes, you see here, I had shown you the descending order. So I want to show you now for the ascending order. I want to show you for the ascending order. Using the same example, I want to show you for the ascending order. So you see, when you write, for example, 1 to 10, when you write 1 to 10, and I want it to be in ascending order in a difference of 2. So here where I had put -3, I will put now 2. So for -3, that one is for descending. But now when you put a number which is positive, that is for ascending. So when I will put here 2, and then I run, you see now it will start now from 1 in a difference of 2. From 1, it goes to 3, 5, 7, and 9. So that one now, it is now for ascending order when you are using 4 in together with a range.
It's time. It's 6:27.
Okay. Up to this juncture, let me allow you for a 5 minutes break. We will be back at 6:32. Thank you a lot.
Before you go for break, please fill in the attendance form if you haven't filled it. I have sent it on the chat. I have sent it again. Please fill in your details. Thank you.
Yes, Levi, can you scroll down a bit and leave it there, somewhere there?
Yeah.
No, come down still. No, up, sorry. Up. Just go up. Yes, there. It's okay.
Okay, I hope you are back. Let us continue. Yvonne, please remind me when it will be 7:10. I finish the class so that we can handle the question session for the remaining 20 minutes.
Okay.
Okay, thank you. So I've taught you the different ways how to use the 4-range loops for either ascending and descending. Also, for the first session of the class, I've taught you how to use the while statement in looping. Now I want to show you, I've shown you the ascending, the descending. And what if, for example, you have been given a range such as -5, 5. That means you are going to have a range which will cover from a negative now value, from a negative value to from a negative value from -5 up to 5. Let me give you an example. For example, you have been given something like this. been given something like this, and then it has been written -5, -5, up to now 5. This means this range within this for loop, it will take care from -5 up to 5. So when you will run, it will give you -5 for no, it will not take care from -5 up to 5. It will. I've told you that for when you are using the for loop statement, this last value is normally assumed. It will go up to 4. So it will give you a range from -5 up to 4. Then the other example, when you have been given range 1, 2, I told you the last value will be assumed. The last value, which is 2, will be assumed, and it will just give you 1. So for example, I've been given this one, and you have been given 1, 2. So it will just, for this case, it will just give you 1. See, it just gives you 1. Then when now you have been given 2 numbers, you have been given 2 numbers. For example, 2 numbers which are the same. For example, 1, 1, it will give you an empty range. For example, 1, 1. Let me run for 1, 1. These are just example. 1, 1. It will just give you an empty range. 1, 1. This way. It will give you empty one. You see, it just runs. It gives you empty. What if you have been given which is range 0 this way, and it has just been written 0 this way? What will it happen? You see, also it will give you empty. Then when you have been given 1, -1, also it will give you empty. For example, 1, -1 this way. When you will try to run, it will give you empty. Then another one is when you have been given 1, -1, then they have told you you have been given now the range. Now, in this case, are given 1, -1. Then they want it in this which order? They want it in descending order. They want it in descending order. This way, -1. So when you run, it will give you 1, 0. So what I want is for you to practice these parts during your free time. Just go and copy what it has been written there. For example, range 0, and you combine it with a for loop. You see what you will get. You see what you will get. The other thing you are going to cover is nested loops. The same way we covered in the conditional execution, where we saw that if can be followed with another if, and also else can be followed with another else. It is the same thing in looping. You will see that after you have written your for or while loop, it can be followed by another 2 if statement or another 2 else statement. And the best example is where now you want to make a multiplication table, which is 10 by 10, where you want to make a multiplication table 10 by 10. So after we go through this example, you will learn very well how now nested loops are used. For example, I will say now print. I want now a 10 by 10 multiplication table. So automatically I want my program to display numbers 1 up to 10. So I'll say print 1, 2, 3, 4 up to 10. Then I want it to be separated. and I want it to be separated by something that looks like a barbed wire. So I'll say print. Then in that print, I put the quotation mark. Then I put those signs. You just put those dashes, and a plus. So that is just the way I want it to be separated. Now, as I've told you, I'm going to use a for loop to make this 10 by 10 multiplication table. And I told you, when you want to use a for loop and you want to print values from 1 to 10, you will say now, in your range, you will say 1 to 11. So I want my rows to have numbers from 1 to 10, and also my columns to have numbers from 1 to 10. So I'll say for range, for row in range 1 to 11. That one I've taught you. That means I want numbers from 1 to 10. Then print. So I want all those numbers from 1 to 10 to be printed in my row. Then this is just a separator, which I want my rows to be separated to columns. I've put that line. What can we call it? Is just a slash. Yeah, that vertical line. So I want it, that is how I want now my rows to be separated to the numbers within the columns. It is just this signs here, which you can see here. Then I say for column in range, 1 to 11. That means I want numbers from 1 to 10. Now I want now to have the product. You all know in a multiplication table, we normally take column multiplied by row. So for example, when I will take this one multiplied by 2, I get 2. 2 multiplied by 2, I get 4. 3 multiplied by 2, I get 6. That way, up to when I will take 10 multiplied by 2, I'll get 20. So I say product now is equals to row multiplied by column. That means I'm computing now the product. Now, I will now apply now the if statement within my for loop. So I'll say if product is less than 100, that is my first condition. Then I have to print. So if the product will be less than 100, I have to print the output, because the maximum output which I can get here is 100, as you can see here. I have to print the output. That is why you see now I'm saying print. I just put the print end, that function. Then if product is less than 10, I also have to print the output, because as you can see, the lowest number I can get here is 1. It is after I take 1 multiplied by 1, I will get 1. And after I take 10 multiplied by 10, I get 100. So you have seen here, if has been followed by another if. That means this is a nested loop, because you see this if and if, it is within the for loop. So when you see now within the loop, 2 if has followed each other, that is what we call a nested loop. Then I say now print the product, print the product. So this means these 2 ifs, the first one, it will take care when the product is less than 100. And the second one, it will take care when the product is less. Yeah, the Zoom had thrown me out of the meeting. I'm sorry. So that is what you can see. The first if is taking care for anything less than 100, and the second if is taking care for anything less than 10. So when this double if is following, the if statement is following each other, that is what we call the nested if. So one application of this nested if is used in making the multiplication table. As you can see, when I run that code, it will make for me that multiplication table. And here you see I've used the for statement, and in between the for statement, it has been followed by 2 if. That is why we call it nested loop. The second example is where now you can make the same program, but in this program, in this first one, you are just restricting it to a 10 by 10. But now, in this second one, you are not restricting it. In this second program, it can make a 10 by 10. It can make a 8 by 8, 15 by 15. It can make any table that a programmer wishes. The difference between this second one and the first one, you saw in the first one, we used for range in 1 to 10, but we didn't set the set the maximum number. Here we have set the maximum number. In this first one, we say for row in range 1 to 11. That means it can only take care up to 10. But when you set the maximum, it can take care up to even if you want to take to make the one of 1,000 and 1,000. So in this one, I started by saying max is equals to 20. I set now my maximum iterative number. My maximum iterative number, I've set it to 20. Now, when I was writing my loop, instead of me writing for range 1 to 11, the same way I had done earlier, 1 to 11. In this one, I've said for range is 1, comma, max. So it means my max, which is 20, which I've set it to 20. I want a 20 by 20. And in the initial one, I told you when you want a 10 by 10, the range will be 1 to 11. Now at 20 by 20, you see I've written 1, then max plus 1. This max plus 1, it means now my max, the value of max here, I had assigned it, my variable here is max. I have assigned it 20. It means when I take this max plus 1, it will give me 21. So it is just the same thing. This means this program, it will display for me a multiplication table of 20 by 20, following just the same procedure, which we have followed in the upper example. But in this one now, we have assigned it to a variable max. So when I will run, you see now here, it will give me a multiplication table of 20 by 20. You see it is 1 up to 20. It is 1 up to 20. It will give me a multiplication table of 20 by 20. When I want, for example, of 8 by 8, what I will just come and do, I will change this 20 here and I change it to 8. I change it to 8. And when I run the same program, it will give me an 8 by 8 multiplication table. 8 by 8 multiplication table. When I want the one, for example, even 3, I'll come here and just put 3. When I run, it will give me a 3 by 3. The difference between setting a max and where I had not set a max, this one is just for specific 10 by 10. But in this one, I can make a multiplication table of any dimension, starting from 1 by 1, 2 by 2. For example, if I can just decide and say for 10, it will still make for 10 by 10. So that is just an application of for loop, and that is just an application of a for loop and a nested loop. What am I saying? This is just an application of a nested loop. In this first one, you saw when I was trying to make my statement, if statement was following each other within a for loop. But in this other, you see now, for loop, for statement is following each other. For statement now is following each other. So where you see now if statement following each other within a for loop, or a for statement following each other within a for loop. That is what we call a nested loop statement. That is what we call a nested loop statement. Further example is when now you want to duplicate some numbers such as A, B, C, D to appear in different forms. You can see you want A, B, C, the second one A, B, D, C. If you want to make such a program, you will have to use the nested loop. You will have to use the nested loop. So in that cell 14, you will go and revise it by yourself, because I've explained it in details when I was making that multiplication table. I explained it in detail when I was making that multiplication table. The other thing before we call it a day is abnormal loop statement. And what does it mean by this abnormal loop statement? So normally a while statement executes until the condition becomes false. The condition is checked only at the top of the loop, so the loop is not immediately exited if the condition becomes false due to activity in the middle of the body. Ordinarily, this behavior is not problem because the intention is to execute all the statement within the body as an indivisible unit. Sometimes, however, it is desirable to immediately exit the loop, exit the body, or recheck the condition from the middle of the loop. Now, sometimes when it is immediate, you want to immediately exit the body of that loop, we normally use a break statement. So a break statement is what now we will cover under abnormal loop termination. This is where now you doesn't leave the loop to exit by itself, but it is like you are forcefully exiting the loop. So the first example, we will use the break statement. It is just the same way as we were doing before. We set now our entry to be equal to 0, then our sum, so that we can initialize. What are we doing? We are setting our sum to be 0. That means we are going now to set our program. If it will get a number which is less than 0, it will exit the loop. But this time around, it will exit the loop by using now the break function, break statement, which is inside an inbuilt function within the Python program. So I'll say while true, so I'm starting my loop, entry is equals to eval. So this means the program is going to accept either an integer or a float. Now I start my first condition. If entry is less than 0, break. So here I'm telling my program, if entry now is less than 0, if I enter any negative number, it breaks. It just breaks and exits the loop. Then if now it is not less than 0, it sums all the numbers which were greater than 0, and it displays the results. That is the meaning when now I say sum plus is equals to entry. That means if it is not less than 0, it sums all the numbers which are greater than 0, then it displays the results by this print function. Now, let me run. For example, when I enter -6, you see, because I've used the break statement, it will immediately exit the loop, because -6 is less than 0. But now, in this case, when I use 89, you see it doesn't exit the loop. When I use 56, it doesn't exit the loop. 45, it doesn't. But when I enter -8, it will exit the loop. And before it exits the loop, it will do the summation of 89, 56, and 45, and it gives the results. So this one, it will exit the loop. But before it exits the loop, it will do for me the summation of 89, 56, and 45, and it gives the results. Then this other example of a code, you will pass it by yourself. It is also, this is where now you are making, you are still making the program to check if your computer has got a problem or it doesn't have. And then it is like you are forcing now, if it gets that the computer has got maybe a default, it breaks and it exits the loop. It is just the same example as this example, but this one, it has got so many lines of codes. So I will expect you to revise by yourself, because I can't pass through all that code. It will take almost an hour. The other thing is the continue statement. Now, the continue statement is similar to the break statement. During the program execution, when the break statement is encountered within the body of a loop, the remaining statement within the body of the loop are skipped and the loop is executed. Now, you see now, when you are using the break statement, when this break function is encountered within the body of a loop, you saw that it exited the loop. But now when you are using the continue statement, it will not exit the loop. It will not exit the loop. What does it mean? It will continue. So in this example, you see, I'm setting my sum is equals to 0. I'm using just the same example. My sum is equals to 0. Then I say done is equals to false. While not done. So while not done, that is my first condition. If while not done, I set now my value, which is the block, and I'm requesting now a value from the user. And this value, I'm setting it to be an even, which it will either accept a float or an int. I'll start now. My first, I say if value is less than 0, what should the program execute? So you see, the if statement is following each other. If statement is following each other, and then in between the if statement, we have got the continue statement. So that means if value is less than 0, I've instructed my program to print negative value, So it will not ignore it the way, to print negative value, then it prints for me ignored. Then continue. So this means it will skip the rest of the body for this iteration. It will continue, and now I'm looking if value is less or is equals to 9,999. So if value is less than 9,999, I want it to tally. It will tally any value which is less than 999. Then it will display for me the sum of that value. Else done. You see now here I'm saying else. So else done, I've said now done if value is 999. So if it gets the value is 999, so that means it is not less than 999. It is equal to 999. So if it gets the value which is equal to 999, it will now exit the loop and it prints for me the sum of that loop. Let me run so that you can visualize it. So you see the program is asking me to enter positive integer, 900 integer, and when I enter 999, it will quit. When I enter anything which is less, it will do the summation. For example, I enter it a 9. You see, it tells me tallying. So it means this program, when I enter this 89, it will tally it. It will tally it. When I enter -6, I've made my program to ignore it. It won't tally. When I enter 67, it will tally. When I enter -90, it will ignore. When I enter 89, it will tally. So the difference here between the break statement, in the break statement, when it immediately encountered a negative, it exited the loop. But here you see, I'm entering now the negative, but it is not exiting the loop. Why is it not exiting the loop? Because I've used the continue statement. So the continue statement, it enables now the program not to exit the loop. But now here, when I enter 999, it will exit the loop, because in this condition, I've said now done. It should be done when the value is equal to 999. And when it is done, it should display for me the tally of all positive numbers, but it should just ignore the negative numbers. So you see here, it will tally for me 89, 67, and 89, but it will ignore -6 and -90. But in the other examples, you saw when I was entering -6, it used to exit the loop when we were using the break statement. But now when you use the continue, it will not exit the loop when you enter a negative value, but it will continue until you enter a number which attains the range of that loop. So that is the difference between the break statement and the continue statement. That is the difference between the break statement and the continue statement. The other example, the same thing, you can write it this way. You say while not done, then you request the values from the user. Value is equals to eval. That means the program can accept either an int or a float. Then you say if value is less than 0, that is the first condition, print negative value. Then it should be ignored. If value is not equal to 999, print tallying. Then done if value is equals to 999. That is just the second way which you can write the above program. You can write it this way. So when you will run, you see, when I enter 89, it asks. When I enter -6, you see now it still asks. So that is the different way. If you don't want to write it having the continuous statement, you can write it this way, not equal to. You see in the first one, I'd written if value is less than or is equals to, but I had included the continuous statement. But in this one, now I've decided to exclude the continuous statement, but from how I've written this code, it just means the same thing as the one above. but that one I wanted to elaborate on the continue. So in this one, you see, I've entered 89, -6, then 67. So when I will enter 999, it will also exit the loop, and it will do the summation of all the positive numbers which I had entered. And that positive numbers, I told you, because I'd used evil, when I can also enter the float, and the program will accept. And the program will accept. The other thing which you are going to pass on is about infinite loop. So what I want you to know about infinite loop, infinite loop is a loop that keeps on running until you interrupt it. That is just the layman interpretation which I want you people to get. It is just a loop which keeps on running up to the time you will interrupt it. If you will fail to interrupt it, it will continue running. It will take even 10 years, but it will keep on running. These are examples of infinite loop. For example, in this program, when I run these codes, it will keep on running. It can take even 10,000 years, but it will not stop running. It will not stop running. It will keep on running and running and running. It can take even infinite amount of time. So what I want you to get, infinite loops are loops that it will run continuously until it is interrupted. That is an example of an infinite loop. The first one, we saw how definite loop behave. We saw how indefinite loop behave. We saw how nested loop behave. Now in this last one, it is infinite loop. This one, it will keep on running. And as you can see, I ran it around 1 minute ago, but it keeps on running up to when now I will interrupt it. This is where now I want you to know one function within the Jupyter notebook. So that function is, we normally call it interrupt. And you see, you will just put your cursor inside that cell, and you go up to where we have kernel. You'll go up to where we have kernel, and you see there is interrupt, restart, restart and clear output, restart and run all, reconnect, shut down, change kernel. So because in an infinite loop, these are loops that it will run forever. You will have to interrupt, and you get now your output. So you will come here and interrupt. So when you have interrupted, you see now it will display the results which you have gotten. But if you could just left it that way, it will still be running up to this time. It will still be running up to this time. And what is an application of an infinite loop? It is normally used in websites. It is normally used in website to enable the website to keep on searching, even if you will search for an item even 100 times, it will keep on searching. So that is one of the application of infinite loop. So you have known how to interrupt. You have known how to interrupt. So when you will be running any cell of an infinite loop, it will run forever. So what you need to know an infinite loop is a loop which will run continuously for a very long period of time without ending. So for you to end that loop, you have to interrupt. Now I will give you an example of an infinite loop. I will give you an example of an infinite loop. For example, you have a number n, you set it to 10. Then you want to get the factors of 10. You say while factor is less or is equals to 10. That is now your condition. Then within the while loop, it is being followed by an if statement. That is what we call now a nested loop. It is being followed by an if statement. And within this nested loop, you see it is intended. You see it is intended. So you say, for if n, then you see this percentage. In our first class, I told you the percentage means modulus. So if n remainder factor is equals to 0, that is a condition, then print factor. And you see after this printing factor, you see there is another factor here, which I have said factor plus is equals to 1. So I want, that means I want the factors to be in differences of 1, 1. Now, when I run this code, you see it just gives me 10. But now, look here, when I want to change it now, and I put it to a factor 2, and I run it. When I change it to a factor 2 and I run it, you see now, when the factor was 10, it just gave me the output very easy. Just gave me the output very easy. But now, when I've put now the factor to be 2, you see these cells, it keeps on running. The cells, it keeps on running. So I have changed it. When I've put the factor to be 2, I've changed it to an infinite loop. Because now you see, I've put the factor to be 2, but you see this factor here, the last factor, I've not intended it with if statement. I've not intended it with, I've not aligned it with if statement. So when I've not aligned it with if statement, this cell, it will take forever to run. It will take forever to run. So for me to interrupt this cell, I have to go to kernel and say interrupt. And when I will interrupt it, it will throw an error. And that error, you have seen it is a keyboard interrupt. So when you see this keyboard interrupt, that means that this thing is an infinite loop and it will take forever to run. But just see, when I will put this factor here, this factor, when I will put it to be aligned with if, when I will put it to be aligned with if, you will realize when I put it to be aligned with if, I want it to, why is it? Let me run it. Yes, when I put it to be aligned with if, you see now it has run and it has given me the factors of 10, which starting from 2, it is 2, 5, and 10. Why has it given me? And in the first case, it didn't give me. Because in the first case, after while statement, it was followed with if. And within that, I wrote that factor within the if statement, within the if statement. So when I wrote within the if statement, it changed from being a nested loop to an infinite loop. It changed from being a nested loop to an infinite loop. So when this last factor, I will move it up to there, it will now change from being a nested loop to an infinite loop. And when it changes from being a nested loop to an infinite loop, and I want the factors of 2, this program will run forever. But when I just put there 10, it won't run forever. It won't run forever. When I just put here 10, it will just give me the factor is 10. But when this factor is being is that way, and I put there 2, because this factor is within the if statement, it will change it to an infinite loop. And when it changes it to an infinite loop, that is why it behaves that way. When it changes it to an infinite loop and I put there 2, it will run forever. So that is the difference which I've done with the first example and the second example?
Sir, it is 7:14 right now.
Yes, a minute. I'm finishing the point.
Okay.
Yeah, now in the last one, it is just the same thing, but now in this way, I want to avoid what it was doing in this one when I put the factor to be 2. So when I want to avoid it, I will say n is equals to 10, n is equals to 10, then I say factor is equals to 2. While factor is less than or is equals to n, I'm instructing my program to print the value of that factor. To print the value of that factor. So if n, this is a modular sign, which means a remainder, factor is equals to 10. Then I'm instructing my program to print that factor. And you see this factor is within the if statement. So when this factor is within the if statement, it changes it to an infinite loop. But if this factor could have been here, it changes it to a nested loop. So when I will run this one, it will just give me those factors, which is 2, 5. You can see there I have got 2. Yeah, it will just give me without running forever. It will just give me without running forever. But if I want it to be a nested loop, I will have this my factor to be within the if function. So when it will be within the if function, when I'll run, that cell, it will run forever. It will just run forever because it will just run forever, and I will have to interrupt it. I will have to interrupt it for it to stop running. And you see, it runs up to the point even it makes my screen to hang. So that means it is just let me move slowly. It has make my screen to hang. So when you say you meet such behavior, just know that is an infinite loop. It just runs forever. Even sometimes it makes your Jupyter notebook to hang. That is an example of an infinite loop. So when you want to stop it, you will just come here to the kernel and say interrupt. And say interrupt. And you wait for it to be interrupted. You wait for it to be interrupted. I don't know if I've interrupted. Yes, I've interrupted. You see, it is writing for me, interrupting the kernel. Don't know how long it will take to interrupt. So that is what I just want to put across. For you, for the first thing, you need to know the while statement. You have to know the for statement. You have to know the, I've said while statement, for statement. You have to know the nested loops. You have to know the definite and indefinite loops, how it behaves. And lastly, you have to know how infinite loop normally behaves. In most cases, when you are dealing with infinite loops, it has to be interrupted, or else it will run forever, or else it will run forever. And in chapter 12, we will learn how now when you get this infinite loop, and in some cases it normally throws an error, we'll learn now how now to exit, how to we will learn about exception, how we will handle exceptions in infinite loops. That is the end of our today's class. That is the end of our today's class. We have only remained with some few things before we call this chapter. So next week, I will finish this chapter with at least 3 examples, so that you can know how iterations are applied in real life situation, such as computing a square root, drawing a tree. So that will just be application of iteration. It will be drawing a tree, computing a square root, and printing prime numbers. And last but not least is where now you want to insist a proper input from the user. I think up to this juncture, that is the end of our class today. Thank you very much. It is now time for questions.
Okay, so if you have any questions, you can ask, though I don't see any questions in the chat. It's just Dan who was getting an error with evil because you have written it in capital letters, a capital E, instead of a small e.
Yeah, you have to write it with a small e. Python is a case-sensitive language. Where you are required to write a capital letter and you write a small letter, it will throw an error. And where you are required to write a small letter and you write a capital, it will throw an error. It is a case-sensitive language.
Okay, does anyone have a question? Okay, so if there is no question, then thank you very much, Dr. Salevi Bushuru, our Technical Director, Python. Yes, that was our lesson today. And I am requesting, if you haven't filled the attendance form, please fill it. It's in the chat. I have sent it. I have sent you the link again. Please fill it. Okay, I will send the recording also. Yes, thank you. That was all for today. Have a
I'm seeing Paul has raised the hand. Paul? I don't know.
Paul
or Owino.
I thought he was clapping.
I was clapping, yeah.
Okay.
Yes.
Yeah, I was clapping.
And when we were starting classes, we were 16. And when we are finishing, I see we are 12. Are the things becoming harder so people are running away?
Maybe it's network issues.
Okay.
Yes.
Okay. Thank you. Unless somebody has got a compliment or a complaint, you can air it before we end the class. Paul Owino, you have been clapping, so you must be having a compliment or a complaint. Air it out.
No, I've just clapped because the lesson was quite interesting.
Okay, thank you.
Yeah.
Thank you a lot. Unless Ruben, you have got any issue, you can air it out because you are remaining with 7 minutes before the class ends.
Not really. We are trying really to internalize and practice the Django. I know, things are becoming complex as we move on, which requires really a lot of practice. Otherwise, good work so far.
Okay, thank you a lot. I think each and every person has got the Jupyter notebook. So I'll just send the slides. I think I've not sent the slide for chapter. I think you have the slide for chapter 2 and 3. So let me send the slide direct away for chapter 4. Yeah, let me send the slides for chapter 4 and 5. And also I'll share the slide for chapter 6 because next week we'll start from chapter 6. And that chapter 6, it will just cover function. And in functions, I think you have got some little idea about functions because what you are doing about square root, those are function. In fact, that will be the first function in chapter 6. We'll just learn about mathematical functions such as square root, cosines, and what have you. There are so many. You'll just know how to import the math library and such things. So each and everyone has got the Jupyter notebook, which I normally use for teaching. So those are just slides for chapter 4, 5, and 6. So we have finished conditional execution. Next week, I'll just take at most 20 minutes to explain the 3 remaining examples. And then I will introduce chapter 6, which is functions. Thank you very much and have a good day.